Okay, welcome again, everyone. We're still on it. We're still on the grind. The heights by great men reach and kept. So we're still on the work. Today we're continuing, of course, naming with our organic species. We're gonna try and name some acids today, and this video is gonna cover straight acids, branched acids, and substituted acids. Okay, but we're gonna take our time. We're just gonna use one example and just kill everything, but just follow. All the procedures will be what you have been exposed to so far. Before we continue, I just want to thank everyone for watching the videos. Thank you for subscribing to my channel. Thank you for all the shares, the likes, everything that you have been doing. Continue to do that for me. Thank you very much. I hope you have been finding these videos helpful. I give them a thumbs up, leave a comment, let me know what's going on with you in terms of the video and understanding the content. All right, so we want to name our acids. Okay, now first things first, the suffix, the last name of acids will be anoic acid, incidentally, anoic acid. Okay, so where the last name will always be anoic acid. Now the good thing about acids is this. I'm just gonna bring this over here a little bit. The good thing about acids is this. This is their functional group. Okay, that's it. And because that's their functional group, this carbon has to be what we say terminal. It has to be at the end of the molecule. Okay, so it's not going to be in the middle. So what you'll find is that naming acids is a little bit easier than naming alkenes, alkenes, alcohols, because of this fundamental fact. This carbon is always carbon number 1. So this is carbon number 1. Always carbon number 1. Okay? Always carbon number 1. If you remember, when you're naming alkenes and alkenes, alcohols, whatever, you had to number your carbon chain to give the OH or give the double bond the lowest possible number. You had to do all of those things. You don't have to do that here. Isn't that great news? Okay, you don't have to do that here. All you need to do is just simplify your carbons, etc., and follow the steps that I'll give you shortly. But just remember, this carbon is always going to be carbon number 1. It has to be. It's at the end of the molecule. And we say that it is terminal, which means at the end, really, not that it's dying or anything. Okay, so that's carbon number 1. And of course, I'll be using the skeletal formula. Okay, so you just need to watch out for that as I do that. So here's an alcohol. All right, sorry, not an alcohol, an acid. Okay, now this part, this is a carbon, of course, double bond O. So this is this carbon, as you can see there, C double bond O, and then you have your OH. All right, so how many carbons? First of all, you need to find out how many carbons are in this acid. So we count 1, 2, 3, 4. This contains 4 carbons. All right, so we then need to find the prefix for 4. Prefix for 4 is bute. So we find bute. Then we add the suffix anoic acid. There you go, butanoic acid. Okay, we're gonna leave the acid part for now because that's just a bit of writing. So it's butanoic acid. Okay, so now we know it's butanoic acid. You don't need to tell where the OH, this functional group is, because it's always carbon number 1. So I don't need to say 1 butanoic acid. And guess what? We're done. This is a straight acid. We're finished naming it already. Okay, you see that it's not so bad now, is it? All right, now we want to look at naming a branched acid. So I find another piece of paper over here, which I'm just gonna use to see if we can do this thing. Let's look at it. Here we go again. 1, 2, 3, 4. So that's my double bond, that's my OH. Okay, so we want to make it branched. Remember, branches are alkyl groups. So I'm going to make a branch right here. Boom, boom, boom. Okay, I just made it a little bit complex because, the more complex it is right now, the more exciting it is. All right, so we want to name this. The first thing we want to do is we want to find the longest carbon chain. So notice how I'm going to count now. 1. You see that? 1, 2, 3, 4. So I found 4. Let's try now. 1, 2, 3, 4, 5, 6. Yes, this is 6. That's true. But watch this now. 1, 2, 3, 4. 1, 2, 3, 4, 5. So we found 4, we found 5, we found 6. Now someone is saying to themselves, okay, the longest carbon chain is 6 carbon atoms long because you got 1, 2, 3, 4, 5, 6. But watch this now. When I did that, the functional group of the acid is not a part of the chain. It would be a branch of the chain, which means that that could not be the longest carbon chain because the functional group has to be a part of the carbon chain, which means that this has to be a part of the carbon chain. Okay, so what we're going to do is count again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There you go. The highest number of carbons is 5 because if we go here 1, 2, 3, 4, that's 4, and down here is 1, 2, 3, 4, 5. So the highest number of carbons is 5. We now need to find the prefix for 5. Prefix for 5 is actually pent, interestingly. Pent. And of course, we add anoic acid. Okay, we add the anoic acid. Good? Now we need to know, we don't need to number a carbon chain. That's the interesting thing. Or we don't need to count to number a carbon chain. We can just number our carbon chain. And I'm going to do that now. 1, 2, 3, 4, 5. There you go. You see that? Now, at position number 2, you recognize that there is a branch. There's an alkyl group there. So we know where the alkyl group is. We now need to identify the alkyl group. How do we do that? We find the number of carbons in that alkyl group. So here we go. 1, 2 carbons. Then you say to yourself, oh, so it's 2 carbons. What's the prefix for 2 carbons again? That's actually ethyl, or eth, sorry. And then, because it's an alkyl group, you add the suffix -il. So this is ethyl, you're not seeing that, sorry, ethyl pentanoic acid. Oh, but we have one more thing to do. We need to tell where the ethyl group is. The numbers tell us where it is. So this is actually 2-ethyl pentanoic acid. There you go. 2-ethyl pentanoic acid. All right? And remember, we don't need to give the position of this because this is always carbon number 1. So this is 2-ethyl pentanoic acid. And this here, right here, ladies and gentlemen, is a branched acid. So you see, we have done straight acid, we have done branched acid, and guess what? We're now going to go on to do the substituted acid. So I'm going to find another piece of paper here for you over here. All right, here we go. Here we go. So there's the paper. Now we're going to look at our substituted acid. Okay. All right, so I'll draw my acid first. Boom, 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 boom. Double bond O, OH. All right, double bond O, OH. And since it's substituted, I have replaced hydrogen with something. Now, previously, I would have used chlorine. I would have used the halogens, chlorine, bromine, iodine. Well, not astatine really, but one of those 4. But I'm going to change it up a bit today. Today, I'm going to use as my substitutes. I'm going to use OH. I'm going to use NH2. Okay. Now, if it is that you use any of these as substituents, guess what? Now, here's the situation. If you use any of these as substituents, they have a special name. Just like how you had chlorine, which was chloro, or bromine, which is bromo. OH as a substituent is hydroxy. So this is hydroxy. Right, that's OH. And NH2 is amino. For those bio people, you will think, oh, amino acids. Yes, it's similar to that. All right. So now I'm just going to make this acid substituted. I seem to like going into the middle section. So I'm just going to put OH there. Okay, so there it is now. Now, some people would say, but why is this not an alcohol? Why is it an acid? And that's a very good question you ask. Why is this not an alcohol? Well, here's the situation. With organic compounds, there's a thing called priority or precedence, where if you have more than one functional group present, then one of those will take priority and the compound will be classed as that group. For example, here we have acid functionality, we have alcohol functionality. So which one is it? The rule is that the acid takes precedence. So this is actually an acid with OH functionality. It's not an alcohol with acid functionality. It's an acid with OH or alcohol functionality. Okay, so therefore this is just a substituent on an acid. It's like you take a friend on a trip with you. It's your road trip. Yeah, you guys are good friends, but you know they're just hanging around along for the ride. So that's what's going on there. So let's name this species now. Now here's the situation. We simply count again the number of carbons in the longest chain. 1, of course, 2, 3, 4, 5. Seem to like 5. So this is pent. And of course we add the anoic because that's how you know it's an acid. So it's pentanoic acid. And I could just put the acid there. All right, so it's pentanoic acid. Then now we can number the carbon chain. Remember again, friends, remember again that this here is always carbon number 1. So that's 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5. So we have numbered carbon chain. We now need to find out where our substituent is. It's right there. It sticks out like a sore thumb. Where is it? Position 3. What is it? Hydroxy. Remember, we use hydroxy. Okay, so therefore we can say that this species, and I'm going to give myself some space now, 3-hydroxy pentanoic acid. It's a bit of a long name, 3-hydroxy pentanoic acid. All right, so you see, you can follow these rules anytime. Just remember, count the number of carbons in the longest carbon chain. Find the prefix for that carbon, number of carbons. Add the suffix anoic acid. All right, and then now you number your carbon chain beginning with this carbon. This is always carbon number 1. After you have done that, based on your numbering, you'd recognize where your substitute is, and then you would also be able to tell what the substitute is based on the structure there. So in this case, it's OH. We know it's hydroxy. All right. So that's how you name your substituted acid. Now, as I promised, I was going to use the amine. Let me get a different piece of paper. As I promised, I was going to use the NH2. So here we go. All right, double bond O, OH, and I'm going to put the NH2 here. Okay, so there you have it. I hope you're seeing that good. I brought it over so you could see. So there's your NH2. So watch this now. All right, count the number of carbons. 1, 2, 3, 4. Prefix for 4 is but, and then butanoic. Okay, then you number your carbon chain. 1, 2, 3, 4. Very good. Where's my NH2? Second carbon. What's the prefix for NH2, or what's the name we use for NH2? Amino. So therefore this is 2-amino butanoic acid. 2-amino butanoic acid. We'll write it right there. Okay, 2-amino butanoic acid. And that's the name of the species. All right, we're not going to do cyclic acids because cyclic acids tend to be quite complex and usually not at the genesis of your organic chemistry. So I hope you guys found this helpful. Thank you for watching. If you have any comments, leave a comment. If there's something you want to ask me, then you know, leave a comment as well, and I'll get back to you with an answer for that. If there's something you want me to explain further, let me know. And please, friends, like, subscribe, share the video, share it with your family and friends. Thank you for watching. All the best in naming your organic species. See you next time.